Question number 2. The first two terms of the geometric progression are 4 sine squared theta and 8 sine cube theta, where theta is the angle such that theta should be less than 1 over 6 pi and greater than 0. Given that the sum to infinity of the progression is 1 by 2, find the value of theta. Give your answer in the form of sine inverse k, where k is the rational number. So we know that geometric progression is a comma ar, then ar square, and then its nth term is ar to the power of n minus 1. We have been given first term and second term. So first term is a1, which is e, and this one is 4 sine square theta, and second term a2, which is ar, and which is equal to 8 sine cube theta. Okay, we know that we can find the ratio by dividing a2 by a1. So ratio is a2 over a1. So a2 is second term, which is 8 sine cube theta over 4 sine square theta, which is first term. So this one it will be cancelled, and this one is also cancelled. So we will have 2 sine theta. So ratio is 2 sine theta. And we have first term, which is 4 sine square theta. And we know that the sum to the infinity is given, which is 1 by 2, and we know that sum to the infinity using formula is a over 1 minus r, and it is given that the sum of infinity is 1 by 2. So when we plug these three values in this equation, we will have 1 over 2 is equal to the 4 sine square theta over 1 minus 2 sine theta. By cross multiplication, we will have 1 minus 2 sine theta is equal to 8 sine square theta. So when we switch these terms on the right side, it will become 8 sine square theta minus 2 sine theta, plus 2 sine theta, and 1 will be negative. This is the quadratic equation, and we can apply quadratic formula or we can use factorization. So factorization is easy in case, for example, negative 1 times 8 is negative 8, and 2, so positive 4 times negative 2 is equal to negative 8. So we can use factorization. So 8 sine square theta plus 4 sine theta minus 2 sine theta minus 1 equal to 0. If we take 4 sine theta from common from first two terms, it will be 4 sine theta, and this will be equal to the 2 sine theta plus 1, and we take negative 1 common, then it will be 2 sine theta plus 1. Okay, 2 sine theta plus 1 can be taken common from both terms. It will be 2 sine theta plus 1 times 4 sine theta minus 1 equal to 0. Okay, we have two factors, so equating each with 0, it will be 2 sine theta plus 1 equal to 0, and on the other side 4 sine theta minus 1 equals to 0. When we solve it further, it will be sine theta is equal to negative 1 by 2, and in this case sine theta is 1 over 4. So we have two values of sine theta. One is negative 1 over 2, and we know that the sine theta has negative value in third and fourth quadrant, whereas theta condition says that theta should be greater than 0 and less than 1 over 6 pi, which is 30 degree. So sine theta is equal to negative 1 by 2. So this angle will lie in third or fourth quadrant, which does not satisfy the given condition. So we can say that doesn't satisfy the given condition or range. On the other side, sine theta is equal to 1 by 4, and when we solve it, theta is equal to sine inverse of 1 by 4, and when we calculate it, it becomes 14.4 degree. So this 14.4 lie in between 0 to 30 degree. So we can say that this angle satisfies the given condition. So theta is sine inverse of 1 by 4, and this is the required format. You can see that sine theta inverse of k, and k is equals to the 1 over 4. Let's move to the question number 3.